Hey there, I'm Dr. Rishi from the Learners Academy, and today we are going to talk about natural numbers. So we have introduced them in our previous video where we discussed about the number system. Today let us break that video into few parts and let us take the first part of it, that is the number system, that is the natural numbers. Today let us take the first part of the previous video where we talked about the natural numbers, and let us talk about natural numbers only and see how we can do operations on natural numbers. So let's talk about natural numbers. As discussed previously, natural numbers are the numbers which are used for counting things. So these are numbers 1, 2, 3, 4, 5, 6, 7 all the way till infinity. Now when we talk about natural numbers, it is crucial to know that 0 is not included in this system. So the first thing, there are four operations that we can do on natural numbers, that is addition, subtraction, multiplication and division. Now let us see how these operations would work, and let us see the properties that are associated with them. So the first operation that we are going to talk about is addition. So when we add two natural numbers, then the final answer is always a natural number. So for instance, if I have 3 plus 4, my answer would be 7, or 2 plus 3, it would be 5. So whenever we do addition, the number that we get after adding is also a natural number. So the number we get after addition is also a natural number. This property is called as the closure property of addition, which basically means that if we add two natural numbers, the answer should also be a natural number. Now, what happens if we have more than two natural numbers and we add them? Say suppose I have two natural numbers, say 3 plus 4, and I add 6 to it. The answer that I would be getting is 7 plus 6, so that is 13. And if I add it as 3 plus 4 plus 6, so I add 4 plus 6 separately, then I would get it as 3 plus 10, so we'd get 13. So if you see, in both the cases, the answer is same, which effectively means if I add three natural numbers and I group them separately and I add them, the final answer would always be equal. That is the way in which, or the order in which I add these natural numbers is not going to matter. So this property is called as associativity. So here this property we call it as closure property, and this property is called as associative property. So in natural numbers, we have closure property and associative property. So this comes under addition. So it's addition of natural numbers. So addition of natural numbers, we can say it follows closure property, or it undergoes closure property, and it undergoes associative property. Now what happens if we reverse the order of addition? So we know if I have 3 plus 4, then it would be 7, and 4 plus 3 would also be 7. This property is called as commutative property, meaning for natural numbers, the order in which we are adding two numbers, so when we consider the addition of natural numbers, then the order in which we are adding, so which number is taken first, doesn't actually matter. So this property is called as commutative property. So addition of natural numbers is, we can say that addition of natural number is commutative, or addition of natural numbers follows commutative property. Then we have identity, additive identity. So additive identity is a number which basically should not change, if added to a natural number should not change the value of the natural number. Since 0 is not included, so we can say that there is no additive identity in natural numbers. The next thing that we have is additive inverse. Now additive inverse also does not exist for natural numbers. Additive inverse is a number when added to the natural number should give its additive identity. However, since there is no negative numbers or no 0 included in the group of natural numbers, additive inverse would not exist for a natural number. This was all about adding natural numbers. Now let's see what happens when we subtract natural numbers. So now we are going to look at subtraction of natural numbers. The first thing that we are going to see is what happens if we subtract two naturals. What happens if we subtract two natural numbers? Are they always going to be, is the final answer always going to be a natural number? No, this is not the case for natural numbers. So for instance, say I have 3 minus 2, then it would be equal to 1. But if I have 2 minus 5, then the answer would be minus 3. Now minus 3 is a negative number. So minus 3 is not a natural number, which means that subtraction would always not give us a natural number, which means that subtraction of natural numbers does not follow the closure property. Let's go ahead and see the next property that is there, that is whether subtraction of natural numbers is commutative or not. So it is, we can say that it is does not follow closure property. Now in same ways, we will see that if I have 3 minus 2, then it is equal to 1. However, 2 minus 3 is equal to minus 1. That means if I reverse the order when I am doing subtraction of natural numbers, I would not get the same answer. So this property, in the previous case we call this property as commutative property. So we would say that subtraction is not commutative. So subtraction, again we can say that it is not commutative. Now since subtraction is not commutative, it would also be not associative, meaning if I have 3 minus 4 minus 3, the answer I would get is 3 minus 1, so that is 2, and I have 3 minus 4 minus 3, the answer I would get is minus, so here 3 minus 2 would be minus 1, minus 3, so that would give me minus 4, which tells me that subtraction of natural numbers does not also follow associative property. So we can say that it is not associative, meaning it would not follow this property. That is, if I group them separately and I do the subtraction, my final answer would not be equal. Okay, so in subtraction we have seen that it does not follow closure property, it does not follow commutative property, it does not follow associative property. Like we discussed previously, there won't be any subtractive inverses, or subtractive identity as well, since there are no negative numbers considered. Now let us go ahead and talk about multiplication of natural numbers. So if I take two natural numbers and I multiply them, what would I get? So I have, say, 3 multiplied by 4, my answer would be 12, or I have 5 multiplied by 6, my answer would be 30. So you can see that if I take multiplication of natural numbers, the final answer I am going to get is always going to be a natural number, which with which I can say that multiplication of natural numbers follows closure property, meaning if I take two numbers, multiply them together, the final answer would be a natural number again. Now if I change the orders, then what happens? So I have 3 multiplied by 4 is equal to 12, also 4 multiplied by 3 is equal to 12, which means that changing the order actually doesn't make a difference at all. So I would say that multiplication follows commutative property. So this is called as commutative property. So we say that follows commutative property. Now if we take 3 numbers, then what happens? So I have say 3 multiplied by 4 multiplied by 5, and I take them in groups. So I take 3 multiplied by 4 multiplied by 5, it would be equal to 3 multiplied by 20, the answer is 60. If I take 3 multiplied by 4 and I multiplied by 5, the answer would be 12 multiplied by 5, which again would be equal to 60. Even if I change from this example, I can see that even if I change the order, group them separately, multiply them in groups, and then finally get the answer, my answer would still be equal, which would make me conclude that multiplication of natural numbers follows associative property. Then we come to multiplicative identity. Yes, multiplication does have identity in natural numbers, and that identity is number 1. So any number, if it is multiplied by 1, the final answer is the number itself. So I have say 7 multiplied by 1, my answer would be 7. Or I can say 7 multiplied by 1 would be 1 multiplied by 7 would be equal to 7. Or 7, say 5 multiplied by 1 would be 1 multiplied by 5 would be equal to 5. Yeah. So this one is called as the multiplicative identity. So 1 we will call it as multiplicative identity. And since 1 is included in the group of natural numbers, I would say that 1 is the multiplicative identity for natural numbers. Now the next thing that we have is multiplicative inverse. Multiplicative inverse would be a number which would give us the final answer equal to 1 if multiplied by our natural number. So multiplicative inverse for 1 by 3 or for 3 would be 1 by 3. However, 1 by 3 is not included in the set of natural numbers. So we would say that the multiplicative inverse would not for natural numbers would not exist, because the final answer would not be included in the natural numbers. Now let us go ahead and talk about division of natural numbers. So let us first see what happens when we divide one natural number by another natural number. Now I have say number 4 and I divided by number 2, my answer would be 2. 2 belongs to natural numbers. 2 is a natural number. However, what happens if I divide 4 by 3? I get my answer as 4 by 3. Now, 4 by 3 is not included in natural numbers, which means that if you do division in natural numbers, the final answer is not always going to be a natural number, with which we can conclude that division does not follow closure property. So division does not follow. So division does not follow division under natural numbers does not follow commutative, does not follow closure property. Now let's see what happens with the commutative property. So if I have 4 divided by 2, my answer is 2, but if I make it as 2 divided by 4, my answer would be 1 by 2. So the final answers are not same. So I would say that division is not commutative or non-commutative, or it does not follow commutative property. So I'd say does not follow Now, let's go ahead one more step and see whether it follows the associative property. So if I have say 5 divided by 10 divided by, say let's make it 50. So let us have 15 divided by 10 divided by 5, and I group them like this. My answer would be, so first I need to solve this. So my answer would be 15 divided by 2. So that would be 15 upon 2. 15 divided by 2. So that would be 7.5. And if I make it 15 divided by 10 divided by 5, my answer would be, so this would be 3 upon 2 divided by 5. So that would be 3 upon 10, so 0.3. So if we would reach to two different conclusions or two different answers if we just shifted the brackets. That is, if we grouped them separately, we would get completely different answers. So this tells us that division does not follow associative property as well. So it does not follow associative property as well. Now let us talk about the identity. So 1 is going to be an identity for division as well, because if you take any number and you divide it by 1, the final answer would be the number that we started with. Identity, we would get identity for division, however we would not get a division inverse, because if you take inverse, it would be again it would become a fraction, and we are not including fractions in natural numbers. Therefore we would say that division inverse of natural numbers would not exist. Now friends, that was all about natural numbers and the basic operations that we can make, that we can have on natural numbers. If you found the video helpful, please give it a thumbs up, like it, do share it with your friends who need this video, and also do subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.